one side limit of piecewise function. I'm Anil Kumar, and what I've done here is that kind of changed the question a bit. So we will look into this question in a different way. Question here is f of x equals to 4 when x is less than equal to minus 2 and is equals to minus half x plus k when x is greater than minus 2. Determine the value of k for the given function to be continuous in the domain of real numbers. So that is the change in the question. So we have to find the value of k so that this piece of function is continuous in the domain of real numbers. That is the question, correct? Let's see how to do it. And how can we really find the value of k so that this piece of function is continuous? So let me start with a sketch. So let's sketch this function. First part is that for x less than equals to minus 2, it is 4. So let us say this is 1, this is 2, 3, 4, the y values. X values 1, 2, 3, 4. So for minus 2, the value is 4. And for less than equal to minus 4, 2, it is still 4. So it's a constant. So that is the first piece. The next piece is that the function is minus half x plus k for x greater than minus 2. Now that is a straight line with a slope of negative. So this line is kind of like this. Greater than minus 2. So that means at minus 2 we must have a hole. Now to make this function continuous, what we have to do is we have to align this hole with this point. If we can do that and then sketch our function, do you understand? Then we can get a continuous function. So that is the concept. So what we really understand from here is that at minus 2, both these pieces should have same value, correct? So let us find the value of this piece when x is minus 2. So if I write x equals to minus 2 and substitute in the second part, which is minus half times minus 2 plus k, it should be equal to 4. That is the value of the first piece at minus 2, correct? So that gives us minus and minus is plus. So we get 1 plus k equals to 4, or k is equals to 4 minus 1 equals to 3. That means if k is 3, then the second piece will have an open circle at x equals to minus 2 and the y value will be 4, which will coincide with the y value or the function's value for x equals to minus 2. And so, since these two pieces join together at the point of discontinuity or probable point of discontinuity, we'll have a continuous function, correct? So that's the whole concept. And from this, we get that k should be equal to 3 for f of x to be continuous. So that is the answer, right? So let's go through this concept once again. Whenever you have a piece of function, then what do we notice? We notice that each piece is continuous, right? Each piece is continuous. That is the first part, right? So we have two different pieces, both are continuous, right? The discontinuity is at that interval where we are splitting the pieces. So if we have same value of the function at that discontinuous point, then the function will be continuous. The other way of putting this is that if limit of the function as x approaches minus 2 from either side is defined and is also equal to value of the function at that point, in this case that point is minus 2, then the function given to us is continuous. So that really gives us the concept of continuity of a piecewise function. So what we are looking for really is that the left side limit, which will be from the first piece less than minus 2, is equal to the right side limit, and therefore the limit exists at this point of minus 2, and it is also same as the value of the function. So when that becomes the condition, then the two pieces will be continuous at that point. So this is the kind of concept we understand from this example, right? Therefore, I've given the title One-Side Limits and Piecewise Function. I hope you appreciate it. So, well, it was easy to figure out what k is. So k is the value which will ensure that the two pieces join together at probable point of discontinuity. And the later half of the video we discussed that technically, if the limit exists at that point and the limit is same as the value of the function at that point, in that case the function will be continuous at that point. I hope you appreciate it. Thank you and all the best.